Okay, so after we started the structural file, let's just go to structural tab. Let's put some columns, and by default we should have a concrete column. Let's go for the biggest one. Just place it somewhere in between the elevations, somewhere here. And let's place another one just aside to it. We're going to change the second one to be another family, so we need to be wood, right? So what we're going to do, we're going to click on it. No, actually no. Let's go to insert. And we're going to load the family on the insert tab. And this is my path. Libraries, then mark structural columns. It needs to be structural columns. Make sure they're structural and not architectural. They are different. And go to wood, to the wood structural columns folder. Don't go to columns, because those columns, they are architectural. They don't link into the structure. Okay, they don't have analytical representation. So let's go to wood, and let's select the first one, M timber column. Okay. Yes. You have the type selector because he has lots of types. We're going to select the biggest one as well, just the last one. Okay. So it's loaded into the project, but it's still not placed in the model, right? So what I'm going to do, I'm just going to select the second column, and I'm going to change it to that one that I have, M timber column, 597 times 597. Okay, so now I'm just missing some kind of foundation on the bottom of the columns. What I'm going to do, I'm going to go to structure, isolated foundation. And on the options on the modify tab, I'm going to say add columns here. If I move to the drawing area, it's looking select structural columns to place isolated foundation. So what I'm going to do, I'm just going to make a selection box, drop it down. It should create the foundation. I'm going to say finish, and I'm going to get a warning. And this warning means that it's out of the view because the view range is not deep enough. But that's something that I was expecting this. So if I go to my 3D, always check your 3Ds, go to shaded, and check if it's doing according to your plans. Everybody has this?
No.
To do the foundations?
Yeah.
Okay. So for the foundations, I'm going to go to structure, isolated foundation, add columns, and then just select the columns. Yeah, now it's doing the top. But I can change here to level 1. Cancel. Add columns, level 1.
Okay. I have another procedure to insert paths, but it's okay.
No, it doesn't. This.
Thinking out loud, but no, come on, it's okay. It's okay.
There is some advantage.
This is Revit as well.
There is some advantage to use add columns, because if you change the columns, then the foundations will follow, and that's the.
Yeah.
We make it work. We make Revit work for us as maximum as possible, because. Okay, so we have our two families. One is wood and another one is concrete, right? Let's click on the wood one, and let's add it to the family on top here. Okay, so after that, let's go to the floor plan. Should we, everybody? Can we go? Let's go to the floor plan. And this is the family creation labels. So we have D on one side, we have B on the other one, and we don't have, if we come here to the properties of the family, we see that we have B, we have D, but we are missing one, because what we need here, we have a specific CO2 footprint that says that in a cubic meter of a certain material, we have a certain amount of CO2 embedded in that material. If it's concrete, because you need to produce concrete, you need to, it's a lot, it's an energetic reaction to produce concrete. You spend CO2, so you emit CO2 to the atmosphere. It's going to be a positive value. On wood, because wood grows and captures CO2 during its lifetime, during the tree time, right? We say that value is negative. Okay, so he embodies in itself CO2 from the environment, and that value becomes negative.
So may I?
Yeah.
In other words, we have to know the volume of every single component. So we have to know the volume of a column, the volume of a path, the volume of a wall. That means the three dimensions: base times depth times height. And then once we know the volume, we have to multiply this volume times the specific CO2 embodied according to that material. We find these data, I mean the specific CO2 from inventories, official inventories, or manufactured products. So we need to know the volume of every single element and multiply that times
The specific
the
CO2.
specific CO2.
In this case, we have two values. So we have an area. We need the height for the volume, right? So we have B and D that gives you the area of the section of the column, but we need the height of the column. We don't have it here. So we need to create something that automatically will report the height to us. So let's go to an elevation, any elevation. It doesn't matter which one you pick. And what I'm going to do here, I'm going to create a dimension, just a single line dimension from the level, attention, from the level until the upper reference level. Just place it somewhere here. And by default, this family is 2,500. But when we put it in our project, according to the levels, of course, it changes the height. So in this case, this 2,500, I don't want to be just a single dimension. I want to be a reporting dimension that tells my database how high is this column in specific different points. Okay. So what I'm going to do, I'm going to select the dimension itself. On the labels, I'm going to create a parameter here. It's going to be a family parameter, yes. It's going to be called age, just small age. Of course, it's an instance parameter because according to different instances, it might change the height. And it's going to go group under dimensions. This is correct. I'm just going to press OK. So this is now reporting to my database. If I come here to the parameters, I should have the age. Okay? So for this specific family, now I need to have inside of the family, I need to create a parameter that's the specific CO2 footprint of this specific material, right? So I'm going to create a new family parameter here on the bottom. And this family parameter is going to be called specific CO2 footprint. It's going to be type parameter, of course, because the material is a type parameter. It's going to be common. It's going to be a number. I'm going to simplify just to be a number. And it's going to be under materials and finishes because this is a material property. Okay? This value, if it is wood,
is
minus
1,000.
Minus 1,000.
Just to have a fast reference on that, if you go to Stora Enso, that is a manufacturer, a producer of CLT and whatever, if you go to the website Stora Enso, I'm actually here, CLT info. If you then click on sustainability, you have these numbers stated here. So they say that 1 cubic meter of wood stores approximately 1 ton of CO2. If you don't believe that, they are very from Austria. Austria. No,
They should be.
It's an Italian way of saying this neighbor. Anyway, they're very precise. They have the documentation attached. And if you don't trust the documentation in German, because you can't read German, there is in English as well. So you can download the document and see that they are saying the truth. This is an official document, and all in all, if you scroll it, you can find stamps and whatever, validity. You will find this number, 1000, minus 1000. What does it mean, minus 1000?
Anybody?
It's collecting CO2.
Exactly.
So during its lifetime, this tree, let's say 1 cubic meter of tree, collected 1 ton of CO2.
1000 kilograms of carbon.
Yes.
Because of the leaves and whatever. Of course, we're talking about averages and blah, blah, blah. But we need to stick with a final number. But let's keep 1000. But with a minus, yes.
And the manufacturer is responsible for this number. So
Yes.
you don't care. You just put the paper from the manufacturer on your file, and you cover your ass.
Yeah, don't forget to mention the sources when you do such a thing, because otherwise it can be a huge Kembe-store bullshit. Okay, so the sources give thickness to our numbers.
Okay, so at this point we have the specific CO2. It belongs to the family, right? So this is a specific family parameter. And now I need to make the calculations for the CO2. It's going to be, the formula is going to be B times D times H times specific CO2 footprint. So I calculate the volume and then I use the CO2 footprint for the volume. At this point, I need to create a parameter, a shared parameter, because everybody knows where shared parameters are, right? It's a text file. It's a text file that's going to be applied into the family, into the project, and into the tag. This will bring consistency to all the parameters, and they will be schedulable, they will be tagged. This enables the possibility of using the same parameter in different files. Okay, that's the idea behind the share parameter. So at this point, I'm going to create a new parameter, and instead of being a family parameter, it's going to be a shared parameter. You're going to come to select. I already did it in last class, but you should have this. You should have this window, right? Just say OK to that error. You should have this window, right? It's a bit different.
Have you clicked on edit?
Yeah, of course, because you need to create one. I'm going to create it with you guys. So I'm going to create a new one, and I'm going to call it CO2 footprint shared parameters for I.
You've got the parameters.
Parameters.
Oh, now it's amazing.
CO2 parameters for I. So this is the name. This is only the name of this text file. Okay, nothing more. I'm going to save it. Save it somewhere you want. You should have a share parameters for your own project, and only one person does it. Of course, only one person does it in the group. No, there's no need for four persons do the same work. Otherwise, when you synchronize, it's gonna say no. So we're gonna save this file, and the Revit asks us all the time to group our parameters under groups. So is that we need to be organized. Nothing special here. We just create a group of parameters called CO2. These files in a regular company, they become really extensive. So then we group them. It's easier for us. If we have more groups, it's easier to sort them out. Okay, nothing really special here. So after creating the group, we can now create a parameter. So we come here, parameters new, and this is going to be CO2 footprint.
Do you know why I get an error saying it cannot be saved, the parameter?
Just a second. I'll go there. No, just CO2. Sorry. It's going to be common and it's going to be number. Okay. How many people cannot create the 2? I guess it's because you are. After creating the CO2 parameter, so we just created the share parameter file. We just put this parameter inside the share parameter file. We're going to say OK. And now we need to put this parameter inside the share parameter file inside the family. So select the CO2 parameter, that's the only one you can select, of course, and let's put it inside our family parameters. As you can see, what brings consistency here is that we are not allowed to change the unit characterization and also the type of parameter. We can change the group, and we're going to group it under material and finishes. Okay, this of course will be an instance parameter because depending on the height, this is looking for the height of the element, right? And because of the different heights of the same element, it's an instance. Everybody understands instance parameters and type parameters. I already did the chair thing, right? Yes. So it's going to be an instance parameter. Let's say okay. And at this stage, this parameter, instead of having a value like the other ones, it's going to be a formula. And the formula is going to be something like this. Two times the parentheses, open parenthesis 2 times. B times D times H. Everything is in millimeters, so it's going to come with an output of cubic millimeters. What I'm going to do, divided by 1. So I'm going to remove the units of the volume, right? Times specific CO2 footprint. Attention to the it's case sensitive, so make sure that you copy this correctly. Okay, so you copy specific CO2 footprint really correctly. So it's going to be, in my case, specific CO2 footprint with a lowercase f. Specific CO2 footprint. If you move your mouse and you click somewhere else, it should create the calculation already. Yes, in my case it did. Make sure when you click outside it starts to create the calculation. It's in grayed out on the value.
It says unexpected end of expression.
It's commas and I'm going there. Just a second. Let me just. Yeah. So it's calculating. It's calculating for me. In my case, because of my dimensions, it gives me 800 minus 890. I'm just going to say OK. So I'm going to load the family and load it back into the project. So what I'm going to say, attention now, this is really important. Load. Do you want to save changes to M timber column in your computer? No. Do you want to save changes of M timber column blah 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 in your project? Yes. Override existing version and its parameter values. Okay, so it's the second one here. First one is no, and the second one is the second. Now, if you click on the column now, on the parameters here, you should have the CO2 parameter here. In my case, it's going to be minus 1068. Because, yeah, it's going to be, this is it's almost 1 cubic meter of wood. Okay? It's working for everybody? Let's repeat this just for the concrete. So we do the same procedures just for the concrete, okay? So let's select the concrete column here. So we do some repetition. So edit family, of course. Let's open the views to see what kind of tags do I have. What kind of dimensions do I have? So I have age and B in this case. I can come here for the parameters. Let's see if they have the height. They don't have the height. I have to create the height again.
Did you open that
Concrete, yes. Yeah. So I don't have the height on my family parameters here, right? So I need to create a height as well for this one. Sometimes it's good to investigate the family before you do the work because sometimes they might already have this parameter inside and you are just duplicating work you don't need. But in this case, we need to do it. So I'm going to go to an elevation. Any elevation, it doesn't matter. I'm going to create a dimension from level to level. I'm going to select the dimension itself and I'm going to create a new parameter based on this dimension. It's going to be family parameter, yes. I'm going to call it just A. And it goes common, length, under dimensions. That's perfect for me. So I'm just going to say okay. If we come to the parameters in the family here on top, now I have the 3 parameters to calculate the volume, right? So I'm good now. I'm going to create another family parameter. In this case, it's going to be the specific CO2 footprint of concrete. Family is going to be a type parameter. Yeah, that's correct, because it's a type of the material, right? And I'm going to call it specific CO2 for concrete. Let's try to make a distinguish here. I think we should, in the next semester, we do it with this distinction for concrete. Okay, type parameter common. This is a number, and it's gonna go under material and finishes. Can I go? Yeah. So in this case, the value is going to be positive because it's emitting, it's creating CO2 for the. When we create 1 cubic meter of concrete, it doesn't absorb, it creates, right? Because it's a really high energetic. And it's going to be 402, right?
Yes, of course, it depends by kind of concrete that you think to use. In the average, according to several inventories, the C35 concrete. Do you remember what does it mean, C35? Sorry, which class is the? It's the compressive class. Of course, remember the mix design, what you learned previously. So, of course, according to several types of concrete, given that you can have different compressive class, different fluidities, the concrete, there are a lot of parameters. Let's say for a standard C35 concrete, that is quite okay. You have this plus 402 kilograms per cubic meters. That's an average. Then I will show you an inventory. That is the one that you can stick with, and you can scroll all the materials and see what does it mean. Yes.
Okay, so in this case,
402 for a C35 concrete.
yeah. In this case, we're gonna assume there's gonna be C35, and we're gonna use 402 positive value. Of course, we don't need to put the plus because it's implicit, but we just put 402. We just get up.
Means that to produce, sorry, Joe,
Please.
to produce that cubic meter of concrete, you polluted the air because of the production itself. Does it make sense?
Okay, so now we have everything. So we have the specific, we have the volume. You just need to calculate the CO2 of this element itself. Because we already have the the shared parameter file, we're going to reuse it again. Okay, so that's why then after this we can schedule both families because this parameter is the same on both. Okay, so I'm going to create a new parameter. In this case, it's going to be my shared parameter, right? I'm going to select the CO2 parameter. It's going to be, this is closed now, common and number. This is what brings unity to all the projects and to all the variables, right? And I'm going to group it. I'm just allowed to select the group. I'm going to put the group under materials and finishes again. Of course, this is going to be an instance because of the volume changes according to the instance. Okay. And I'm just going to press OK. Yes?
I'm not really sure again why we're doing this extra step because, like, in my head, I would just do the calculation like A times B times H, that formula. Why is it again we have to parameter?
Okay, so we need to create this extra parameter because this is the specific one, right? This is not a formula itself, so it doesn't adapt to the. Because the idea here, the volume is not constant. This family here, this example of family in the family editor is 2,500 the height, right? My height in here is 2,500. In my project, it might be 3,000 or 3,050, depends on your height of the levels, right? So this is going to change the volume according to the family. right? If you move the level, the CO2 adapts. Wait. Then I have something that is fixed. 402 is fixed because it's a cubic meter. It doesn't matter. It's a cubic meter of concrete, 1 by 1 by 1, 402 kilograms of CO2, right? Now I have to make another calculation for the one that varies. For the one that is fixed, I'm going to have the CO2 of this element. I don't know if I understand your question. I don't know if you understand what I'm explaining, but maybe try to rephrase your question. Maybe. Okay. Inside the tag family itself, what I'm going to do, I'm going to change the label. So at this moment, this tag is reporting a label, right? One label. And the label is reporting the family, the type name of this family, right? Of the columns. I don't want it to report the type name. So I'm going to go out. I want this tag to report the CO2 footprint. And if you look at it, I don't have the CO2 footprint in here, right? So I need to create one. Based on the share parameters that we had before, I'm going to select the CO2. Okay? I'm just going to press OK. The CO2 now becomes available for my selection. I'm going to select it by double clicking on it. And the sample value is called CO2. And this value will of course pick the information from the family itself. But I'm going to put a suffix here. I'm just going to say kilograms. So then my tag reads a number and then kilograms. I'm going to say OK. Load into the project and close. In this case, do you want to save M structural column tag CO2 in your computer? Yes. It's loaded. What I need to do now, What I need to do now, I need to come to the tag that I have on the columns and change it to the CO2 tag. Okay. Okay, so the tag is done. What I need to do now, I need to schedule it. So I just need to create a schedule for my my end goal is to have a schedule where the end is going to be 0 or negative, right? So on schedules, I'm just going to write in schedules, new categories, new schedule quantity, sorry, structural columns, and I'm going to do base level, CO2, and what more? Family and type. Let's go for family and type. And I would like to have the other level, the top level. I'm just going to organize my lists. So I'm going to have family first on my columns. Then after that, the base level. After that, the top level. And then my CO2. Okay? Under grouping and sorting, I'm going to group it by CO2. At the end of the schedule, I want to have the totals. Because what I'm going to do, I'm going to add both columns together to see my footprint of the building, right? I'm going to add them together. In formatting, in the CO2, I'm going to make the calculation of totals. Should we go through all the tabs to make sure that you guys have this correct? Let's go to fields. Fields, family and type, base level, top level, and CO2. On filter, we're not going to filter anything. We want to see everything. On sorting, we are doing the CO2. We want to see the grand totals, the totals. And of course, we want to itemize every instance. We want to see all the columns, right? Under formatting, on CO2, we're going to calculate the totals. Okay? So I'm going to press OK. And this is my schedule. In this case, because the column of wood is so big and so massive, the CO2 footprint of these two columns it's negative. But of course, your building might be different because you have an entire foundation of concrete and some structure and the superstructure. Do they have the cores of the elevators in concrete?
They could.
Yeah. So your values, I don't know what's your experience, Livio, but the values they go zero. They go to zero normally. No. But anyway, this is a way to track your.
Not that with the numbers that we have.
Yeah. Okay. Any questions?
So this stuff here should be presented for your skeleton from the very bottom of the foundation up to the last